Hello everyone, it's Benny, and in this video we're going to be talking about making generic shadows. Now in the last couple of videos we set up some pretty nice looking soft shadows, but well, they're very limited. We can't just say put a light here and check the enable shadows button and have everything just work. They're very limited, they're very finicky, and they only work with directional lights. So we're going to be correcting that in this video. And even though we've started with the directional light, I'm actually going to do spotlights first, because shadow maps actually tend to work best with spotlights. And then we can reuse most of the spotlight stuff for implementing directional lights and whatnot, but yeah, we're starting with spotlights. So what I've done off-screen is I've changed my test scene. Of course, I've enabled the spotlight, so the spotlight's now back in the scene. Our point light isn't anymore, but our spotlight is. And I've added all these lines of code, so this is the new rotation and position and such, so there that is. And one more tiny thing is I changed the attenuation to 0.02f here, just because I thought it was falling off a little too quickly. You know, otherwise the directional light just washed it out because it's so powerful. So yeah, if I build and run, and just for our directional, and I haven't changed anything else, this is just changing the parameters of the spotlight, making it a new position with a slightly different fall off, then you notice a few things. First off, of course, we have a spotlight now. Second off, it doesn't have a shadow. And third, it's not working in the shadow of the directional light. So yeah, that's not exactly what we're going for here. And the reason this is you might remember, we actually wrote some code explicitly so this doesn't happen. We wrote code to detect if a light isn't supposed to be casting a shadow, and if it isn't, get rid of everything in the shadow map so we don't have this issue. But we didn't update it for our new variance shadow map system. And that one's using colors and such, so yeah, we need to update that, essentially. So right now we're just clearing the depth buffer. Variance shadow map also writes to the color buffer, so let's also clear the GL color buffer bit. Just use a bitwise OR there, build and run, and well, it's now there's no spotlight at all. And the reason this is basically it's clearing the depth to 0. And well, that's not what we want, because that means everything's always going to be in shadow. So I'm going to change the clear color, so it's 1.0. So 1 means completely in light. So, you know, yeah. Well, you know what I mean. That's the depth, so that everything will be completely in light. And there. Now our spotlight's shining through the shadow of the directional light, and basically that issue is all taken care of. So great, now all we have to do, now that we've got that working, is actually, now that we do have that working, I'm going to disable the directional light so that we're just looking at the spotlight. We're only seeing, yeah, the spotlight, all the awkward non-shadowness of it. So yeah, so this is what the scene looks like with a spotlight and no shadow. And now let's go ahead and modify our shadow mapping code so that this cube is indeed casting a shadow. So, the way we add shadows to a light is by setting shadow info, at least in this system. Now right now we're setting some shadow info on our directional light, and that's the whole reason we have shadows for our directional light. So I'm just going to copy that line that sets shadow info and paste it in the spotlight. So now our spotlight's going to be generating some form of shadows. They're going to be totally wrong because the parameters are for directional light right now, but it'll generate shadows of some kind. So that'll be the next task. Let's set up the parameters so that they're appropriate for a spotlight. Now, the two parameters it's taking in, or that it requires, is a projection. That's what this whole orthographic matrix thing is, at least right now. And you know, the projection's supposed to be, well, the projection matrix used in generating the shadow map. So again, right now it's an orthographic matrix because in a directional light, all the light rays are supposed to be parallel. And an orthographic matrix preserves that. All objects are looked at as if it's, a parallel projection. Spotlights, however, we don't really want that. What we actually want is a perspective projection. So I'm going to create, a perspective projection. And that'll mean, light rays are sort of going out at some form of angle. They're spreading out in sort of a cone, which is exactly what a spotlight's doing. And I'll fill out the parameters for that in a moment. But the second parameter for shadow info that we require is whether or not we should flip the faces when we're rendering the shadow map. And in this case I set it to true because I found the directional light was reversed if we didn't. Spotlight, however, I don't think we're going to have that issue, so I'm going to set it to false. We might end up needing it, so I'm going to leave it there just in case, but for now I'm going to set it at false. And so that just leaves setting the parameters for the perspective matrix. Now the perspective matrix takes in 4 parameters: a field of view, an aspect ratio, a near clipping plane, and a far clipping plane. Now you might not think we have a field of view because it doesn't look like we're taking in one, but believe it or not, we are taking in a field of view. We're just not taking it in as an angle. You see, our spotlight has this parameter called the cutoff. And it's been a while since we discussed this, so just to refresh your memory, what the cutoff does is, essentially, it's storing some value for a cosine. So this will be a value between -1 and +1. And if the field of view, not the field of view, if the light direction, so the light ray is going off in some direction, and if the cosine between that light direction and the direction that the spotlight's supposed to be going in, so the cosine between those, as long as that's greater than the cutoff, then that's fine. But if it's below the cutoff value, then, that's not in the spotlight's sort of cone, so that ray isn't going to be used. And that's the way our cutoff works. It's definitely not the most intuitive way to set the spotlight cutoff, I don't think, but, it's workable. So essentially, you can think of it like, if the cutoff is at 0, then it's a 180-degree field of view. If it's at 1, then we're looking at a straight line, so that's a 0-degree field of view. And since this is supposed to be representing a cosine, we can use the arc cosine to get the inverse of that. So I'm going to take the arc cosine of the cutoff, but you gotta be careful here, because I just said, if the cutoff is 0, that's supposed to represent a field of view of 180. What's the arc cosine of 0? That will be a 90-degree angle. So, it's giving us that, 90 degrees if this is 0. And that's not what we want. We want 180 degrees. So, I'm actually going to multiply that by 2. So there. And that's how we're going to get the field of view. Now, aspect ratio. That's going to depend on the aspect ratio of the texture that's being used to generate the shadow map. Of the shadow map, I should say. It's going to depend on the aspect ratio of the shadow map. And I am going to have a way so that, I believe later in this video, if all goes according to plan, that we can set the resolution of a shadow map. But to make this easier, I'm going to constrain it so that you can only have square shadow maps. So just to make things easier, they're always going to be square, so the aspect ratio is always going to be 1. Now z-near, I'm just going to hard-code it 0.1 for now, because that tends to be a good z-near value. And z-far, we actually already have calculated this somewhere else. That's the range of the light. So if I use this arrow range, there we got the z-far. So now we have shadow info for our spotlight, and if I build and run, we should see shadows of some sort. And what do you know? Look at that! Our spotlight is now casting shadows. Just like that. All we had to do was set up the shadow info. Now granted, right now, the edges are a bit razor hard, and, I think the shadow map might be a little bit too high resolution, 1024 by 1024 is a lot of resolution for a spotlight this small. So yeah, we definitely need to work out a few kinks, and also I think the light bleeding value might be a little too low for this. But, you know, again, we have a few kinks, but clearly the general idea is here. So, yeah, let's start tweaking this and getting this working a little bit nicer. So, now that we at least have our spotlights casting shadows, it's time to add a few more parameters to our constructor for our spotlight, so that we can, control all the shadow casting aspects of it. How soft should the shadows be? How much resolution should the shadows have? Should it cast shadows at all? Things like that. And I'm going to start by changing our cutoff thing, because I don't think that's the most intuitive way to set the viewing angle of the spotlight, essentially. So what I'm going to do is I'm essentially going to reverse this. Instead of taking in the cutoff, I'm going to take in the field of view. And I'm basically going to do this field of view calculation we have right here in reverse to calculate the cutoff based on the field of view. So the cutoff is going to be initialized to the view angle divided by 2, and it's going to be the cosine of that. So great. You're probably going to want to rename it in the spotlight header. Now I actually did that off screen. I set the view angle, or renamed to view angle, and set it to default to 179. And in main, we're going to want to change that 0.7 to the new system. And again, I calculated that off screen, and it's roughly 2 radians of 91.1 f. And now if I build and run and all that such, I should have shadows looking, just about the same as they were before. Maybe not exactly, it was 91.1 and a little bit more, but I think that's a good approximation. So great. That's got us our first new parameter. Also, make sure the view angle is defaulting to 2 radians of 179.0, and not just 179, because, again, all our angles are internally being represented as radians. So yeah. Now, for the rest of the parameters for Spotlight, the first parameter is going to be the shadow map size. What's the resolution? And this is going to be a bit interesting, because the way I'm going to do that is I'm going to specify the shadow map size as sort of a power of 2. So there's going to be int shadow map size as power of 2, which is going to default to 0. So for instance, if I set this to 10, then the shadow map resolution would be 2 to the 10th power, which is 1024, and so the resolution would be 1024 by 1024. Or if I set this to, say, 6, then 2 to the power of 6 is 64, so the shadow map will be 64 by 64. And that's how I'm going to specify it. And there is a reason I'm specifying it like this, which I'll talk about a little more in a moment. But for now, I'm just going to leave it at this. That's how you're going to specify it. And if it's at 0, that means that this doesn't cast any shadows. So that's how we're going to tell if we're casting shadows or not. And for the rest of the parameters, that's basically going to be the rest of the parameters for shadow info. So I'm actually just going to copy that. So shadow softness, going to default to 1, light bleed reduction, going to default to 0.2, and min variance, which is going to default to 0.00002f. And great. So those are all the parameters related to shadow mapping. I'm going to copy them here. And let's see. Right here. Take in, don't need to copy all the parameters, but do want, or the default parameters, but I am going to want the values. And I'm going to want to put that on a new line, just so that everything aligns up nicely. And there. So, again, if my shadow map app as size of 2 is not equal to 0, that is when I'm going to set shadow map info. So, there. And, I can delete that comment now. Yeah, and the rest of the parameters are going to be whatever they pass in. So shadow softness is going to be there. Light bleed reduction amount is going to be that. And min variance is going to be whatever they pass in for that. And wonderful. So that should be just about... well, almost everything. I actually am going to want to mess with shadow softness a bit in a moment, but again, let's just build right now and see what happens. Just to make sure I haven't destroyed everything. Now, okay, cool. We have destroyed everything. And the reason is because in my main, I have the default parameter for the SpotLight is 0 for shadow map size, so I can set that to 10. That'll be 1024 by 1024. And great. So now we got a shadow being cast. The thing I want to change is the way the blur amount is used in the blur shadow map function. Now right now I'm doing 1 over the shadow map width or height times the blur amount, and that's how I'm setting the blur scale. And that's great, and I had this nice system set up, but recently I realized what I'm ultimately trying to do in that whole system I had was control this value right here, which is how many texels we move per sample. So yeah, I'm just going to change this around so that the blur amount is the number of texels we move in the blur sample. So blur amount divided by that. And there. And that's a lot nicer. And what I'm going to do here is I'm going to have some float, I'm going to call shadow softness, which equals shadowinfo.getSoftness, or arrow getSoftness. So just extracting that parameter from here. And the reason I'm going to do that is because if shadow softness is equal to 0, I only want to blur the shadow map if the shadow softness is not equal to 0. So, yeah. And doing it this way is a lot simpler than the system I had before. So, I'm going to be using it this way. And right now I actually think that, yeah, the shadow softness defaults to 1, so it shouldn't change anything. I don't think. So yeah, I believe that corrects the whole shadow softness situation. So if I, again, build and run one last time, just to make sure we haven't broken anything. Alright, we've got this shadow map. So, aside from the shadow map size, all the parameters for the shadow map are working. And just to test it out and play around a bit, well, you know what? Yeah, I'm going to save that for once we have the shadow map size set up. So now, let's get it so that we really can specify the shadow map size. Now, here's the reason I've decided to do this wonky power of 2 texture size system. You see, if I have a texture that's, say, 1024 by 1024, okay? And I generate MIP maps for it. That's going to generate a texture that's 512 by 512, and then another one that's 256 by 256, another that's 128 by 128, and so forth and so on. And you notice that's just a list of all the power of 2s descending. So if you specify dynamic shadow map resolution with powers of 2 like this, then you can implement the entire dynamic resolution system with MIP mapping. And that's kind of nice. But I'm not actually going to do that in this video. And there's 2 reasons for that. First off, I haven't actually talked about MIP maps on my channel yet, and I don't think it's fair to start throwing out a bunch of stuff that I've never talked about before at you. And secondly, our texture class isn't really designed to support it yet either, so if I wanted to do it, I'd need to go in and write a whole bunch of basically extra code just to allow us to select the exact bitmap to bind, and well, I don't really want to do that in this video. So for now, we're just going to implement it with a whole bunch of different textures. But again, later on, you can implement this with just MIP maps, and that's, I think, really nice. So I'm going to define a new private variable in renderingengine.h. It's going to be a static const, and it's going to be an, it's going to be an int. I'm going to call it num shadow maps. And, well, actually, yeah, num shadow maps. I'm going to set that to 10. So that'll mean 2 to the 10th power, which is 1024 by 1024. Again, as I said in the shadow mapping video, 1024 by 1024 is generally a pretty good upper bound for shadow map size. If you need a shadow map bigger than that, you probably aren't doing something right. So that's, yeah, again, generally a good maximum size for shadow maps, at least I've found. And with that, I'm going to modify my rendering engine so that I have an array of texture pointers. So, yeah, right here, I'm going to have a texture pointer that I'm going to call mShadowMaps, and it's going to be an array of size snum shadow maps. So, these are all our shadow maps. And that's going to mean we're going to need... And actually, I almost forgot, we're going to need another one. A second texture map array of shadow map temp targets. Because again, we gotta do the blurring thing, and that requires a secondary render target. And, well, yeah. So, cool, we got all these. Now, since we are managing things like that now, we aren't going to need to set texture like this anymore. We're not going to need to do that at all. So, those can go away, actually, entirely. It also means in our destructor, we're going to need to do a for loop. So for int I is 0, I is less than snum shadow maps, because, you know, gotta delete all this. And for this whole loop, I'm going to say if mShadowMaps sub I, then delete mShadowMaps sub I. And there. And that should... Oh, and of course do it for shadow map temp targets. Keep forgetting about that. But yeah, once you do it for shadow map temp targets, yeah, we got all our shadow maps generated and deleted. So there. Now, this does make our actually binding shadow maps here and deleting them later slightly more difficult, but it won't be that big of a deal. So, now in here, in my constructor, I am going to make a similar for loop to this deletion loop, so in fact I'm just going to copy it. Except rather than deleting the shadow maps, this is what's actually going to create it. So I'm going to say mShadowMap sub I equals, and this is where I'm going to create it as a new shadow map. So I'm just going to, yeah, copy and paste the line that used to be creating the shadow map and put it here. Now actually I'm going to have some inf I'm going to call shadow map size. And here's how you can calculate that. What I'm going to do is I'm going to take my iterator variable. Oh, actually I'm going to take my iterator variable. I know. Hang on, one moment. What I'm going to do is I'm going to take 1, and I'm going to shift that left by my iterator variable. So at 0, it's going to be 1 shifted left by 0. So it's going to be 1. At, well, when I is 1, it's going to be 1 shifted left by 1, which is 2. At 2, it's going to be 1 shifted left by 2, which is 4, and, you know, it's always going to be a power of 2. So there. And that's how I'm going to get the shadow map size. And I believe after this I can do... what's it called? Yeah, I can just initialize shadow map temp target to the... if I don't delete everything, I can initialize shadow map temp target to the exact same thing. So, great. We've initialized all the shadow maps. So, yeah, I think I might have just done something wrong, actually. And, yeah, I'm actually going to want to shift this left by I plus 1. So, we're actually enforcing a minimum shadow map of 2 by 2 like this. But, yeah, it works. So, there. So now we've got all our shadow maps initialized, we have them all being deleted. What we don't have is, well, our rendering engine. It's still set up to use the old shadow map system. So, let's change things around a bit. And unfortunately, that's going to make things a little bit more complicated here. Because now, we don't just have one universal shadow map that we can bind as the render target and then clear. So, we're actually going to have to change this if shadow info to an if else. If we don't have shadow info, then, well, we're going to need to change, we're going to need to have some default shadow map. So, I'm going to set texture, set shadow map to a texture, and it's going to be m shadow maps sub 0. And I'm also going to say m shadow maps of 0, just bind as render target. So there. So by default, we're just going to end up using the smallest resolution shadow map. Otherwise, we can get rid of this, and in here, we can select a shadow map and do whatever based on, well, you know, based on the index that's stored in our shadow info, which we don't have right now. But I'll do that in a moment. For now, I'm going to say shadow maps of 9. So we're going to be using what should be the, I believe, yeah, the 2 to the power of 10 one, because it's the highest resolution thing. So 1024 by 1024 should be the same as before. And final thing we're going to need to change is blur shadow map, because this is depending on shadow map temp target. So what I'm going to do instead of taking in a shadow map, I'm going to take in int shadow map index. So, whoops. So there, that's how this is going to work. In fact, here, I'm just going to have some int shadow map index, which I'm going to set to this. So, there. Just to make things a little bit more reused and such. So, rather than taking in get texture shadow map, we're going to take in blur with shadow map index. So let's build. And we get an error. First error. Didn't change the prototype in my header file, so yeah, let's go ahead and fix that. I'm going to take in int shadow map index. Let's try again. Also, I don't think don't actually have the shadow map, so I'm just going to create a texture point here called shadow map, which equals m shadow maps sub shadow map index. There. And I'm also going to have some texture pointer temp target, which is m shadow maps temp targets subindex. There. And just so you know, technically you don't need to have the bitmapped list of shadow map temp targets like I'm doing. I'm just doing it anyways, just to save some fill rate, I suppose. So yeah. So there, build and run, and hey, what do you know? Our shadow map is still working like before. So now let's make it a parameter. Let's make it, you know, actually do something. So in lighting, I'm going to add, yeah, it's going to be a parameter for shadow info. In fact, I'm going to do that off screen because that's pretty basic. Okay, so I've added a new variable in our shadow info for int shadow map size as power of 2. It's being just very basic, has a getter, that's all there is to it. So I am going to need to change my lights so that they actually use this. So in my SpotLight, I'm going to pass in, you know, of course, the value passed in, the shadow map as size of set power of 2. And just going to put out a new line because I think it's getting a bit long. And there. And for directional light, I'm just going to pass in 10 for now because that's what's being used. So there. And finally, in my rendering engine, to use whatever shadow map size that they need, I'm going to do shadow info, get shadow map size as power of 2, and I'm going to subtract 1 to get the index. So, if I want power of 10, 2 to the 10, which is 1024, then I'll take 10 minus 1, which is 9. If we would want 256 by 256, that's 2 to the 8th, so that'll be 8 minus 1, which is 7, which is, again, correct. So, with all that out of the way, I should now have the power to, first off, build, make sure I don't have any errors, and, well, yeah, cool. Make sure everything works. Alright, so this is still working. So I should now be able to edit my SpotLight a bit. So right now I'm passing in 10. Let's change that to 8. So this will be a 256 by 256. And you can tell it's a lower resolution because, well, the edges are a bit softer. Yeah, in fact, I wonder how low I can go. Can I go all the way down to 64 by 64? I might be able to, actually, in this case. Yeah, I'm starting to play around a bit now, but yeah. And with 64 by 64, I say that's working, oddly enough. So yeah, you can go all the way down to just a 64 by 64 shadow map, at least in this case, and still get a pretty good-looking result. Though in fairness, I think it is a little bit too soft for the distance of light, so maybe 7 would be better. So, yeah. Again, I'm just playing around at this point. And also, let's add in some other parameters. Let's make sure they're all working, too. So, IntelliSense is failing me, and I don't have them memorized, so after that, there's shadow softness. So, let's set this to 0. So now we should have basically no shadow map blurring occurring at all. And I honestly can't tell if it's happening or not, so, at least not at this resolution, so I don't know if that's a good thing or a bad thing. I'll turn up to 1024 by 10... Whoops. Wrong button. I'll turn up to 1024 by 1024, and apparently I'm getting a segmentation fault when it's closing, so that might be a bad sign. Okay, so yeah, it is being quantized like that, and I know why that's occurring, actually. Because at my destructor, I still have something set as the shadow map, so what I need to do here is, where I have set texture shadow map, I just want to set that to 0, so that way I'm not trying to delete it twice, and that should fix it. But yeah, I think this is quite interesting. I can actually... Yeah, there is no filtering going on the shadow. This is just pure linear stuff, and it looks just fine at this... So, I think that's kind of cool. I'm going to leave it like that. And you notice no more segmentation fault. Okay, I was playing around with things off-screen, and one thing I discovered is that any field of view above 170 really just starts to break down. The shadow map just has too much distortion to be accurate. So I'm setting the field of view to default to 170 instead because, in fact, let me show you. At 170, I think the distortion is at an acceptable level, but yeah, once you get beyond that, like 175 or 179, even worse, yeah, things just really start to break down. So yeah, this, okay, this is acceptable. Beyond this, not quite as acceptable. So yeah, I'm going to change it back to 91.1 like I had before. And just show you, yeah, this is what the shadow ended up looking like after I finished playing around with everything. And yeah, so at this point, I think it's safe to say we have general spotlights. They have all the parameters you could ever want. Well, maybe not all you could ever want, but most of the parameters you'd want for just adjusting the shadows, getting them just right for your scene. And you know, it's nice like that. So, with that, I think the spotlight can be considered done. We have generic shadows for spotlights. But we still need to handle directional lights. We've got some things going on here with directional light, but it's not at all perfect. So that's going to be our next task. Just messing with directional lights and making things work in a general fashion. But I'm going to save that for the next video. So, thank you. Hope you enjoyed. Hope you learned. And in the next video, we're going to be implementing generic directional lights. And we're also going to talk about some of the challenges with making these lights with generic shadows play nice with each other. So, thank you. Hope you enjoyed. Hope you learned. And I'll see you next time.